So I want to figure out what the slope is. Now, this is a function. I'm going to call this function f of x. I'm really creative with my names for my functions. So I'm going to call this function f of x. And from f of x, I know the equation. If I want to pick a y value out for any x value, I plug in that x value, and it will give me my y value out, or my f value out. So I know everything about it. Now, the slope here, let's just say I'm talking about the slope at this value right here. If I put a tangent line up to it, touching that point, then I would have the slope if I knew the equation of the line. But the only problem is I'm only going to know one point right here. So if I only know one point, then I can't get the slope. So what I'm going to do is the next best thing here. I'm going to construct a secant line on the graph. Because for a secant line, I can actually figure out 2 points on the line. So I'm going to take my second point and I'm going to put it right there. And that's going to be my secant line. Now, you notice it hugs the curve pretty good right there. So it's a good approximation of what the slope is here. So let's see what we have here. So this is going to be x, and I'm going to let this point right here be some x plus h. And I come up here, and this has a function value of f of x. And right here I have a function value of f of x plus h. So to get the slope of this tangent line, and again I'm interested in this slope right here at this point right here, I would say that the slope of this is f of x plus h minus f of x all over x plus h minus x. I've got x, and I've got x plus h, so it would be x to f of x plus h, and this is f of x plus h. So the slope is your change in y values over your change in x values. And if I need to put that in parentheses, I can. Now, that is an approximation for the slope. But I could get just a little bit better with my approximation of my slope. Can you throw me that red marker? So, thank you. So I could get, if I move in right here, I could let this be my new x plus h. So this would be my new distance h here. So this could be my new x plus h. And this would be my new f of x plus h. And if I construct a secant line going through these 2 points, then I get an even better approximation of what the slope would be right there. See how the pink line hugs the curve just a little bit better than what the green line hugged the curve. Now, I could do even better than that. And I could do even better than that by moving this value in just a little bit closer. So the closer my 2 points are together, this x and this x plus h, the closer those 2 points are together, the closer I'm going to be my slope. because I'd still have 2 points, could figure out my slope from it. And ultimately, we would love for that h value to be 0. Because if that h value is 0, then I'm on that same point, and I've got my curve here. I'm sorry, I've got my slope here. So, I'm talking about, I need that h value to become 0. So to find the slope of a line, it's going to be the limit as h approaches 0 of f of x plus h minus f of x over x plus h. I'm going to drop the parentheses, minus x. Now, in the denominator, notice what happens. The x's would cancel out, right? So we have the limit as h approaches 0 of f of x plus h minus f of x all over h. And that's what we're going to be calling the derivative of the line. And we use this notation. The derivative of the line, we use the notation of f prime of x, which is just an apostrophe if you're typing it in, but f prime of x equals to the limit as h approaches 0 of f of x plus h minus f of x over h. Now, we can't cancel out right here. You don't solve this out by distributing the x plus h. You can't distribute the f with both of those terms. In other words, that doesn't become f of x plus f of h minus f of x. That's not what's happening there. So let's take this back into consideration, and let's go back and look at the parabola that we had earlier. And let's say that we want to know what the slope is at this point when x is 2. So find the slope of f of x equals x squared at the point 2, 4. And I'm going to do that problem on my next video here.